expand as much as possible. And here we have the log expression, log base 2 of 32x cubed in the numerator and 9yz to the fourth in the denominator. All right, so what does it mean to expand? Okay, so the idea is that here we have one log expression, right? It's a log and it's a little bit messy in here, right? So we see the numerator and denominator. There's actually 5 different terms here, right? We got a 32, we got the x cubed, we have a 9, a y, and a z to the fourth. So there's 5 different terms here. So when we expand, okay, we don't want to have one log in the final answer. Okay, we want to have 5 in this case, right? Because there are 5 terms in the argument. Okay, so what we want to do is first, how are we going to expand? Well, we use the rules for logs, okay? There's no particular order, right? You can use either the product rule or the quotient rule first, but I like to use the quotient rule first, okay? Doesn't really matter, okay? But we'll use the quotient rule first, then we'll use the product rule second, and then, this is the key though, we have to use the power rule last, okay? Remember, we can use these rules in order to sort of separate these or expand these guys. Okay, so what does the quotient rule say? The quotient rule says that if we have one log, right, we can break it up into the log of the numerator minus the log of the denominator. So let's go ahead and do that, right? We have log base 2 of 32x cubed minus log base 2 of 9yz to the fourth. Okay? So we broke it up into the log of the numerator minus the log of the denominator. But then we notice once again, okay, I see a product here, right? I see the 32 times x cubed and the same thing here, right? So what does the product rule say? The product rule says we can break these up into the sum, right? So we're going to have log base 2 of 32 plus log base 2 of x cubed. Here's where you got to be really careful, right? This minus is going to distribute to all of these guys, right? So, for example, we can write it like this, right? Log base 2 of 9 plus log base 2 of y plus log base 2 of z to the fourth power, right? But eventually this minus sign should distribute to all of these guys. So log base 2 of 32 plus log base 2 of x cubed minus log base 2 of 9 minus log base 2 of y minus log base 2 of z to the fourth power. Okay? Hopefully you recognize one thing here, right? You see how this is a positive log? This is positive. This log is also positive. These are all negatives, right? Notice any positive log, that term ended up in the numerator, and any negative log, okay, these terms ended up in the denominator. And that's very important, right? So I could switch these around, right? Move these terms around. But as long as you keep track of the sign in front, right, that essentially tells you which term goes in the numerator, which term goes in the denominator. All right, no, we're not done yet because we do have to use a power rule, right? Remember, what does the power rule say? The power rule says that the power of the argument can come in front and become the coefficient, okay? Now, okay, actually, this one we can actually do, right? Log base 2 of 32, right? What does that equal? Right, that just equals 5, right? Because 2 to the 5th power is 32, so we'll rewrite that as 5 plus 3 log base 2 of x. This one, we can't do anything with that, right? Log base 2 of 9 minus log base 2 of y. And then this one, this 4 can come up front, and we'll write that as log base 2 of z. And this here, right, this is going to be our final answer.